Hello everyone, good evening. Welcome back to Gate Wallah English YouTube channel. I hope everyone is doing great. So in today's class, we will try to finish infiltration. So till now, we have covered losses of precipitation. Okay, losses from precipitation, and we have covered all the losses. Okay, we'll discuss, we'll have a quick recap before starting, and then we'll solve some great questions today in today's class, and we'll end this infiltration topic. Okay, so before starting, everyone kindly comment that I am fully audible and visible to you all, and good evening everyone to all those who have just joined the session. Okay. Good evening, everyone. Good evening, Sushil. Good evening, everyone. Everyone kindly comment that I am fully audible and visible to you all. Then I will begin the lecture. Okay. So, till now, basically in last class I told you about, yes, I told you about the infiltrometers. Okay, I hope you all remember the infiltrometers. And flooding type infiltrometer was there, rainfall simulator was there, which was better. Obviously rainfall simulator was better. Then we went on to discuss about what was Horton's equation. Wait a second, we should discuss, I think, the entire thing. Okay, so yes, in losses from precipitation, very first topic which we discussed was evaporation. I hope it is very clear to you. In evaporation, I told you what is the basic definition, what are the factors on which evaporation depends. Okay, then I told you that in factors, atmospheric pressure, vapor pressure, when they increase, evaporation goes down. When wind velocity increase, temperature increase, surface area increase, then evaporation increases. Okay, only this much you have to remember. I told you all these things. When water quality goes down, then also evaporation decreases. These are the factors. After factors, I went on to discuss how to measure evaporation. I told you about evaporimeters, okay, in which we discussed basically pan evaporimeter. In the class A land pan has coefficient pan coefficient of 0.7. Indian pan has pan coefficient of 0.8. We have to multiply pan evaporation by these coefficients to get the actual water body evaporation. Yes or no? I hope we have discussed this. Okay, I think you all know this. Then after evaporimeter, we went on to discuss the empirical equation, which is the Mayer's formula. Okay, I hope you remember it. What was Mayer's formula? Sir, Mayer's formula was lake evaporation is equal to Km, okay, EW minus EA bracket 1 plus U9 upon 16. This was the formula. I hope you remember it. Okay. After Mayer's formula, I told you the analytical methods. In analytical methods, I told you about water budget. And then at last, we went on to discuss how to reduce evaporation. Can you name the two chemicals which I told you? Can you name those two chemicals? Everyone kindly comment. Good evening, dear. Good evening, Keshav. Okay, tell me the name of those two chemicals. Sir, the name of those two chemicals are, tell me everyone, kindly comment. See, let me check if you are able to remember it or not. Tell me the name of those two chemicals. After evaporation, I went on to discuss evapotranspiration. In this, I told you about potential evapotranspiration and actual evapotranspiration. So, do you remember it or not? Tell me. Do you remember the name of the chemicals? The name of the chemicals were, very good, cetyl alcohol was there and stearyl alcohol was there. Cetyl alcohol and stearyl alcohol. These chemicals basically are non-toxic and forms a thin film over the surface of water. That's why water molecules are unable to escape to the atmosphere. Okay, I hope you remember this. Perfect. Evapotranspiration, potential evapotranspiration and actual evapotranspiration, we have discussed both of them. Potential means the maximum value when your climate is at its best. Okay, climatic condition, it depends on climatic condition also, how your sunshine is, what is the temperature, and your moisture condition should be optimum. Moisture should be sufficient. But when moisture is not sufficient, then according to real situation, the evapotranspiration which takes place is known as actual evapotranspiration. Can you name the meter? Can you name the meter with the help of which we measure actual evapotranspiration? I hope you remember it. This is an important question. It will be asked in GATE examination. Tell me the name of the meter with the help of which we measure actual evapotranspiration. Everyone kindly comment. Yes, great. Great, Sushil. Now tell me actually evapotranspiration meter. The meter is lysimeter. Okay. Yes, lysimeter is the one. I hope you remember it. Then after this evapotranspiration thing, we went on to discuss what draughts are. Okay. After evapotranspiration, lysimeter was important. Then Penman's equation was there, Blaney-Criddle equation was there, which measures PET, but it was not so important. Okay, so I'm not going to discuss that. After PET, we went on to discuss about drought. Okay, drought and a different type. So drought is a condition of, you can say, scarcity of water. Okay, sir. Meteorological drought was there, hydrological drought was there, agricultural drought was there. Meteorological drought means when you can say more than 25% decrease in precipitation is there. Agricultural drought is measured by an index known as aridity index. Very important. This is very important. Formula for which is given by PET minus AET upon PET into 100. Okay, you have to remember this. This is aridity index, and we wish that this aridity index is as low as possible. Okay, it should be very, very low so that dryness is less and crops are flourishing in your fields. Okay, so this was AI. Then we discussed some theoretical part. After droughts, we went on to discuss interception. Okay, interception, I hope you remember. Then depression storage. After depression storage, we started infiltration. Okay, already. What is infiltration? I told you basic definition of infiltration. What are the factors? On which your infiltration depends, that we also discussed, like what is the type of soil, is there any kind of vegetation cover, what is the texture of soil. Okay, and vegetation cover, characteristic of soil, rainfall characteristics. Yes, I told you about rainfall thing. If rainfall is more, then I will see some part will go into the ground and some part will remain, will go in the form of runoff. Okay, but yes, if rainfall is less, when rainfall is less than infiltration capacity, then at that case, sir, all the water will be absorbed on the ground and I will see no runoff. This is very important concept. Okay, so this we have already discussed. Now after this we went on to discuss the entire concept of simplified equation. We discussed that the major losses infiltration, we will neglect all the minor losses. Okay, so P minus infiltration is equal to runoff. This we discussed. I hope you remember this equation. Okay, and infiltration is measured by two kind of meters, that also we have discussed. After this we went on to discuss your Horton's equation in the last class. Okay, after infiltrometers we discussed Horton's equation. Horton's equations are basically, this is the simple equation in which we can find infiltration capacity at any time t. Basically infiltration capacity at any time t decreases exponentially with time, sir. This you have told. And sir, the most important thing is this total depth of infiltration, which has been asked in examinations many a times. Okay, tricky questions have also been asked, so we will solve some great questions which has been asked in your GATE examination today itself. Okay, so I hope you are ready, and these kinds of example we have already discussed. So I hope you know how to do integration and what should be the units. Okay, you have to be careful with the units because sometimes it is given in minutes and you have to put it in hours. So you have to remember which unit has to be put at which place. Okay, how to find average, how to find total depth of infiltration, how to integrate from time t1 to t2, that you can understand. Also we have noted one thing in the last problem which we have solved yesterday. We have noted down one thing, that initially see, if we are taking same time duration, then in initial phase obviously the infiltration depth will be more. Okay, let us say this is the first half hour, this is the second half hour. So obviously in the first half hour the total value of infiltration will be more as compared to in the second half hour. Okay, if you have same time duration, but if that time duration is earlier, then total depth of infiltration will be more. Yes or no? That you should understand, because you can see the graph area goes on decreasing exponentially. So initially we have more depth of infiltration. This you can appreciate. And then at last we discussed when your time is very, very large, let us say for 6 hours, 8 hours, 10 hours, 12 hours. Obviously this is a large time when it comes to rain, obviously. Yes or no? So I already told you that whenever we have large time, then this formula will be utilized. Okay, FC into T plus F0 by FC upon KH. Simply use this formula and get the total depth of infiltration. So this was also important. Now we'll move ahead and solve some great questions today. Okay, now we'll move ahead, and this is your 15th lecture of hydrology. Today we are going to discuss some awesome questions. Wait a second. Let us have a blank slide. So this is the question which you have to solve. We don't have a blank slide here, then wait a second. Yes, so what this question is saying, try to understand. Till then let me insert some slides so that, yes, now its slide is there. Great, now we'll solve this question. Okay, so in this question what this is saying, rainfall over a basin in 3 consecutive hours are 4, 5 and 3 centimeter respectively. That means in the first hour we have 4 centimeter rainfall, in the second hour we have 5 centimeter rainfall, and in the third hour we have 3 centimeter rainfall. Okay sir, clear. Estimate the surface runoff from the base in assuming negligible surface retention and evaporation losses. Okay. The infiltration loss can be estimated using the following equation. Okay, this is your Horton's equation. Equation is also given to you, and in this equation, infiltration capacity is in centimeter per hour and time is in hour. Okay, so how I will estimate it? This is a very good question. With the help of this, you will be able to understand the entire concept of infiltration very clearly. Okay, okay, sir. So how I will solve? This is very important question. So first you need to make hydrograph. Okay, be very attentive. Okay, be very attentive. This is very important question and little tough also. Okay, so tell me, if 4 centimeter rainfall is happening in 1 hour, so what is the intensity in the first hour? Can you tell the intensity? Can you tell the intensity? Yes, sir, for sure we can tell the intensity, because in the first first hour, rainfall intensity will be 4 centimeter per hour. Okay, let us draw here. Let us draw here the 4. Wait a second. Yes, so this will be 4 centimeter hour, 4 centimeter per hour. In the second hour, it is 5 centimeter per hour. Okay, in the second hour it is 5 centimeter. 5 is little more than 4 centimeter. And then in the third hour we have intensity as 3 centimeter per hour. Okay, this is intensity versus time graph. We have to draw hydrograph. Okay, this is 3 centimeter per hour. Let me draw here. Yes, so this is your hydrograph which you have already drawn. I is, wait a second. Yes, I is what? I is intensity in centimeter per hour, because this question is saying that intensity here is mentioned in see, everything will be in centimeter per hour only. This is 4, this is 5, this is 3. This is 4, this is 5, and this is 3. No problem, sir. Understood clearly. And this is first hour, second hour, and third hour. Here we have time, and that too in hour. Sir, clear? Very clear. See, in this question you will understand the concept. Now you need to understand, they are saying, see, we have to firstly, what we have to do, we have to draw this infiltration curve. Okay, so how I will draw this, how I will plot this infiltration curve? Okay, how I will plot this infiltration curve? See, whenever your time is 0, tell me, when your time is 0, tell me, at t equal to 0, what will be the value of infiltration here? Tell me. Put the value of t as 0. E power 0 is 1. 1 into 4.2 is 4.2. 4.2 plus 1.2 is how much? When time is equal to 0, at that, in that case, the infiltration capacity will be equal to F naught. Yes or no? And it is coming out to be 1.2 plus 4.2. How much it is? Everyone kindly comment. This is equal to 5.4. Okay, 5.4 centimeter per hour. Yes or no? And when time is very large, when t is tending to infinite, in that case, your Ft will be equal to Fc, and that is coming out to be C. Put the value of t as infinite here. E power minus infinity is 0. This we have already discussed yesterday. E power minus infinite is 0. Yes or no? This is 0. 0 multiplied by anything is 0. So F will be equal to how much? F will be equal to only 1.2 centimeter per hour. Okay, sir. Very clear. Now, so I will start this graph from 5.4 and end this graph on 1.2. So I have to draw it here. Okay, we have to draw it here. We will draw it. Listen very carefully. You have to be very attentive if you want to understand this great question. So 5.4 will be above 4, above 5 also. So 5.4, let us say, will be somewhere here. Let us assume this is 5.4. Okay, this graph will go sharply. Okay, this graph will go like this. This graph will go like this. Okay, this graph will go like this, and after certain time it will become constant, and the value of this constant will be 1.2. Okay, this will be constant, and the value of this constant will be 1.2. Yes or no? Tell me yes or no. Okay, this will be going here like this. So this is the graph. This is the Horton's equation which we have plotted here. Okay, this is the Horton's equation which we have plotted here. I hope this is very clear to you. So now what we will do, now what I will do here is that we have to estimate the surface runoff. We have to estimate the surface runoff. So what? See, one thing you need to understand. Whenever, if I want to find runoff means what? So runoff will only happen when, see, listen very carefully. Runoff will only happen when intensity of rainfall is more than ft. Is this thing clear? Runoff will only happen when intensity of rainfall is more than infiltration capacity. But whenever intensity of rainfall is less, then no runoff will take place. No runoff. This we have already discussed. Because rainfall is less, all the water will go into the ground itself. No runoff will be there. Yes or no? So when you are looking at this graph, listen very carefully. When you are looking at this graph, I will see that up to here, up to this point, we'll find this time, obviously. We'll find this time. No, don't worry. See, up to this point, up to this time t, you can see that infiltration capacity is more and intensity of rainfall is less. Rainfall is less. Yes or no? Can you appreciate this fact? See, up to this point, up to this time, you can see that infiltration capacity is more, and intensity is less. So you will see that till here, no runoff will be there because rainfall is less. Yes or no? But if you will go ahead of this time, you will see that you have more rainfall than this infiltration. Rainfall is more. So this area will give you the runoff. This area will give you the runoff part. And the area below this graph, will give you infiltration. Yes or no? Simple. This we have already understood, sir. This we already know. So what I want to say is that before this time period t, we have no runoff, but immediately after this time t, I will see runoff. Why? Because intensity line is coming above infiltration line. Yes or no? Infiltration line is less, intensity of rainfall is more. So when we have more rainfall, then only runoff will be there. Okay, sir. Understood. This is very, very clear to me. Now, see, we are interested in finding this time value. We are interested in finding the value of this time. Can you find this time? See, this is simple, sir. Sir, I want to understand where this line is cutting this point. See, you need to understand the value of the value of infiltration capacity is decreasing from 5.4. It is going on decreasing 5.4, 5.2, 5.15 like this, and it is becoming equal to 4 here. Okay, this is becoming equal to 4. Yes or no? It is becoming equal to 4. Understood, sir? So this means the value of f has become equal to 4 at this time t. Yes or no? It has become equal to 4. So I will write when f is equal to 4. Okay, when f is equal to 4, put the value of f is equal to 4 here. 4 is equal to 1.2 plus 4.2 e power minus 2.5 t. Okay, when f is 4, find the value of time. So from here, when I will solve, 4 minus 1.2 divided by 4.2 is equal to e power minus 2.5 t. Okay, solve this number. This will be 2.8 upon 4.2. Solve this. This is 14 to the 14 3 2 by 3 0.66. Take log on both sides. Take natural log on both sides. This will be natural log e minus 2.5 t. Natural log e is 1. So this will be minus 2.5 t is equal to minus something. This is natural log 2 by 3 will be minus something. Minus minus will get cancelled. Divide this number by 2.5. You will get the time. Divide this number by 2.5. You will get the time. Tell me how much it is coming. Tell me. I will also solve this in my calculator. So we are getting it as somewhere. Wait a second. Let me also solve this thing. So we are getting it somewhere. Log 2 by 3, ln 2 by 3 is coming out to be minus 0.4054. Okay, negative cancel. Divide this number by 2.5. We are getting it as minus 0.16. Minus 0.162. Simply we can say that t is coming to be, when f is equal to 4, then from this equation t is equal to 0.162 or simply 0.16 r, which means this time value is 0.16. Let me write here 0.16 this time. So you need to understand one thing. That before 0.16, no runoff. Yes or no? Can you understand this logic? Simple. Can you understand this logic? Tell me. Kindly comment yes if you are able to understand this thing. I will say that before, or let us say when, let us write here, when time period is less than 0.16 r, we can see from this graph we can see from this graph that intensity of rainfall, which is 4 centimeter per hour, is less than infiltration capacity. My graph is going is above than intensity of rainfall. Infiltration curve is above intensity of rainfall. Yes or no? Yes or no? Can you understand this thing? So when T is less than 0.16, then I can say that intensity is less than this. So I will say no runoff in this zone. No runoff, zero runoff, zero runoff. Okay, and whatever rainfall will be there, sir, whatever rainfall, see, this is the amount of rainfall, this is the amount of rainfall, whatever rainfall will there, it will go into the ground itself. Whatever rainfall is there, it will go into the ground. No runoff, you will see. No runoff. All this 4 centimeter per hour multiplied by 0.16 hour will go into the ground. Yes or no? Are you able to understand this thing? Kindly comment yes once. Okay, so that I am able to understand that you are getting it. Okay. Okay. But after this you will see, after this time period, let me write when my time period is beyond 0.16 hour, I will see that intensity of rainfall always is more. Intensity of rainfall is always more than this infiltration curve. Infiltration curve is lower, intensity of rainfall is more. So obviously in this case, we will see runoff will occur. Okay, runoff and infiltration both will occur. Okay, some will see, this area will be giving you runoff and the lower area will be giving you infiltration. Okay, so I hope this thing is clear. Now, if you want to find the total infiltration, what I will do, listen very carefully. See, in this question, they are also assuming that surface retention and evaporation losses all are zero. They are neglecting all the minor losses. They are saying no evaporation. They are saying no surface retention. No water has been retained in the depressions on surface. No, all minor losses are zero. Only infiltration is there. Okay, only loss is infiltration. They are saying, simply they are saying that only loss is infiltration. So if you want to find the value of total infiltration, how I will evaluate it, sir? It's very simple. Total infiltration will be calculated how? See, from this curve, listen very carefully. The shaded area, which I will shade in green color, see, this water will be, whatever rainfall is there before 0.16 will go into the ground directly, and after 0.16 we will find the area under this infiltration curve normally. Okay, we will find area under this infiltration curve normally, as we have did in the last class. Okay, we have calculated the total depth of infiltration simply by integrating, okay, to get the area under the infiltration curve. This we have already discussed. So here we have the common process, but one thing which we have learned here is, one thing which is new here is, whenever infiltration curve is more, whenever infiltration capacity is more than rainfall, then obviously all the water will go into the ground and no runoff will take place. In that case, sir, I will not find the area between the in that case, sir, I will not find the area under the infiltration curve, but I will find area under the intensity curve, intensity of rainfall. Yes or no? That's why I have drawn this hydrograph thing and infiltration curve simultaneously in the same graph itself. Okay, yes or no? Yes or no, dear? Sushil, solve once again. I am getting it. I have also solved it. I am getting it as 0.162. Okay, I am very sure about this value. Kindly check once again. See what you have to do, Sushil. 4 minus 1.2 divided by 4.2. This will be somewhere around 0.66. See, you are taking log base 10. But it should be log base E. Okay. Log base E will give you 0, will give you one value. Okay, I understood what mistake you are committing here. See, this is, till here everything is clear. You have to take natural log on both sides. Natural log will give you negative of minus 0.458. This will be 1, and minus 2.5t will come back side. Okay, so take natural log, not log base 10. This is the mistake that you are committing, I guess. Okay, now how I will find infiltration? Sir, we have to find the area of this green part. Now first I will find the area of this thing. So 4 cm, see, this is 4, and this is 0.16. So 4 multiplied by 0.6. 4 multiplied by 4 centimeter per hour multiplied by 4 centimeter per hour multiplied by 0.164. This is the total rainfall. This is the total rainfall before 0.16, which is going directly into the ground, no runoff. Yes or no? If we put f equal to 5.4, then we have 0.16. No, dear. If we put f equal to 5.4, then time will be 0. Okay, if we put f equal to 5.4, listen very carefully. See, 5.4 value is when time is t is equal to 0. See, if you will put 5.4, 5.4 minus 1.2 is 4.2, 4.2, 4.2 will get cancelled. You will have 1. Yes or no? In that case, you will get the value of time as 0 because natural log 1 is 0. Natural log 1 is 0. Okay. Okay, Sushil. I think you are very clear now. Okay, now let us find the area, Sushil. Okay, now let us find the area. So area of this thing is 4 into 0.16, this rectangular part. Then after this, we will find the area under the curve. See, tell me if you want to find the area under this curve, how I will find? Can you tell me how I will find? Yes, I have understood the mistake that you are taking natural log, not taking natural log. I have already told you. Okay, so we have to integrate from 0.16 to 3. We have to integrate from 0.16 to 3. Okay, this infiltration equation. So this is our equation. This is our beautiful equation. I will write here. I will write here. Okay. I will write this equation as 0.16. I will write this equation here. 0.16 to 3. Equation is 1.2 plus 4.2 e power minus 2.5t dt. Okay, so you will solve this thing. See, this part will give you, see, you can solve this directly in calculators. Directly this will give you the answer in calculator. Okay, no issues. This will give you directly answer. But if you want to integrate, you can do this 1.2t plus 4.2 e power minus 2.5t divided by, this is the coefficient of t, you have to divide it by 2.5, negative 2.5. Now put the value, you have done the integration part. Okay, see, this is 3, put in place of t 3, then put 0.16 in place of t and subtract them, you will get the answer. You will get the answer. Okay, so when you will solve it, see this part, this is simply 0.64 centimeter, and when you will solve this, let me tell you how much you are getting here. Try to solve quickly. See, in calculators you will get it directly, you will get this integration directly. Okay, so when I will solve it, 1.2 plus 4.2 e power minus 2.5, e power minus 2.5, limit is 3 and 0.16, we are getting it as 4.53, 4.533, simply 4.53 centimeter we are getting here. Okay, yes, so total value, the total value will be 5.173. The total value will be 5.17 simply. The total infiltration is 5.17. Okay, so this area is 0.64 and this area is 4 point something. Total area, total this green shaded area is 5.17. Okay, I hope this is clear. Perfect, Sushil, you are also getting it. Great. Now tell me what will be the runoff. See, can you tell me the total precipitation value? Can you tell me the total precipitation value here in this case? Sir, total precipitation value in this question is, see, in the first hour we have 4 centimeter rainfall. Sir, in the second hour we have 5 centimeter rainfall. In the third hour we have 3 centimeter value. So total precipitation, total amount of rainfall which has occurred in this 3 hour is 4, 5, 9, 9, 3, 12. Yes or no? Perfect. Okay, if you will compute the area of these 3 rectangles, this will be equal to 12 centimeter. 4 plus 5 plus 3, 12 centimeter. Now what is the runoff? Okay, if you want to find, see, in this question they are saying estimate the surface runoff. So if you want to estimate the surface runoff, you should appreciate the fact, if you want to find the surface runoff, you should appreciate the fact that we have to subtract infiltration from total precipitation. Yes or no? From this total precipitation, you have to subtract infiltration. Tell me how much you are getting here. Total precipitation is 12 centimeter. Total infiltration which has occurred in this 3R is 5.1 centimeter. So tell me the value of runoff. Everyone, how much runoff is there? Tell me how much runoff we are getting. Subtract this. This will be 6.83. 6.83. Yes, this is 6.83. Okay, this is simply 6.83. I hope this is clear to you. If you want to see this part in graph, okay, yes, 6.827 is the correct answer. If you round it off, you will get it as 6.83. See, if you want to see where is runoff in this graph, we will shade it with some different ink. Let us use this ink. See this area which you are seeing here, which is above this infiltration curve, this is runoff. Okay, this color is representing runoff. This green color is representing what? This green color here is representing infiltration. Okay, so out of this total rainfalls, or out of this total rainfall, this is runoff, this portion is infiltration. I hope this is very, very clear to you. How you will solve, now you are able to understand. See, one thing which I want you to understand is from this question is, see, such kind of question can be easily seen in your gate examination. Okay, this type of questions are very common, so listen very carefully. Now what I want you to understand from here is that let us say this is your infiltration curve, and these are the values of rainfall. I will discuss 3 cases here. See, in these cases you are seeing that intensity. See, in the first case, curve is going, infiltration curve is below. In this case also infiltration is more than infiltration. In this case infiltration is more. In the third case also infiltration is more. In the fourth case infiltration is more. So infiltration, sorry, I have to write infiltration. Infiltration is denoted by F. Yes, I'm sure. Sorry, this is intensity of rainfall. This is intensity of rainfall. So intensity of rainfall is more. 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 When intensity of rainfall is more, in all the cases, no issue, sir. Simply find the area below this curve. Simply find the area below this curve, which will give you infiltration, and the area above this curve will be. Tell me, this will be runoff. Below curve is infiltration, and above this curve is runoff. Simple. But let us change this question. Let us say this is your hydrograph, and let us assume your infiltration curve is like this. So you need to understand here, in the first hour or in the first 2 hours, whatever time it is, here we have infiltration curve value more. Intensity of rainfall is less. Here intensity of rainfall is more. Here again intensity of rainfall is less. Here again intensity of rainfall is more. So sir, I can see that intensity of rainfall sometimes is less, sometimes it is more. Whenever intensity of rainfall is more, then only runoff will take place. Okay, you should appreciate the fact here, this is the runoff. But in the first hour and the third hour, you will see that whatever rainfall is there, all the water will go into the ground. All the water. See, if you want to find the infiltration, here I will find the area of this rectangle. Then I will integrate from 1 to 2. Then again I will find the area of this rectangle. Then again I will integrate from 3 to 4. Yes or no? So you need to understand, when I have to find the area of rectangle. Area of rectangle will be required when intensity of rainfall is less than infiltration capacity. Is this thing clear? Tell me. Is this thing clear? Good evening, Hemant. I hope you are doing great. Great, Hemant. So I hope you are able to understand this thing. Okay, so whenever your intensity of rainfall is less, then I have to find the area of rectangle. I will not do integration, sir. To find the infiltration, I will not do the integration. In that case, whatever is the intensity of rainfall, I will simply multiply by time. Whatever rainfall is there, it will go into the ground. Sushil, is this thing clear? Tell me. Is this concept clear to you? This is the ultimate thing which I want you to understand from here. Okay. Now we'll move ahead. Now we'll move ahead and discuss new concept of phi index. I hope Horton's equation, from Horton's equation you will be able to solve all kind of questions. This is one of the, you can say, this is one of the best questions from Horton's equation. If you are able to understand this, then obviously you will be able to solve other part also. Okay, so everyone kindly comment that if you are able to understand all these things. Then we'll move to phi index. After this we have to discuss what is phi index. Okay, so I hope till here everything is clear to you. Okay, now we'll discuss what is phi index. We have to discuss what is the phi index. Okay, so acha, second case, Sushil, you are saying second case. See, second case is simple. Sushil, listen very carefully. Sushil, listen very carefully here. See, this is intensity of rainfall. Okay, this is intensity of rainfall. Okay, you need to understand, sometimes let us take some values. Sometimes rainfall is 3 centimeter per hour, sometimes it is 8, sometimes it is 2, sometimes it is 7 centimeter per hour. Okay, this is first hour, second hour, third hour, fourth hour. Now this is your infiltration curve. This is your infiltration curve. So Sushil, what we have learned in yesterday's class, that whenever we have infiltration curve, and if I want to find total depth of infiltration, listen very carefully. How I will find total depth of infiltration up to this time t? I will simply integrate up to time t. Yes or no? I will simply integrate up to time t, and I will get the value of total infiltration. This you have already learned. Yes or no? Yes or no, Sushil? But this formula, this integration thing is only valid when, listen very carefully, when intensity of rainfall is more every time. Every single time intensity of rainfall is more. Intensity of rainfall more than f. Intensity of, see, this is intensity of rainfall. Okay, this is intensity of rainfall, intensity of rainfall, intensity of rainfall, intensity of rainfall, intensity of rainfall more than f all the time. Then I will simply integrate. But you need to understand here, see, in the first case intensity of rainfall is 3. This value is declining from, let us say, 5. This is declining from 7 to 6, 7, 6, 5, like this. And after, let us say, after some time it is becoming equal to 3 and constant from there on. Okay, so in the first part, sir, I can say that intensity of rainfall is less than f. In the second R, I can say that rainfall again is more, intensity of rainfall is more than f. Here I can say that intensity of rainfall again is less than f. And in the fourth R, in the third, in the last R, first, second, third, fourth R, I can see the intensity again is more. Okay, so whenever intensity is more, no problem, simply integrate. Whenever intensity is more, and if you want to find the infiltration value, simply integrate. You will integrate from 1 to 2, you will integrate from 3 to 4. Okay, if you want to find infiltration, you want to find these areas. Okay, you want to find these areas, you have to simply integrate from 1 to 2 ftdt. Here also you have to integrate from 3 to 4 ftdt. Okay, listen very carefully. But here you will not integrate. Why? Because you need to understand, you will, if you will integrate, you will get this area, and this area is even more than rainfall. Sir, rainfall is only 3. How you can find this area? Rainfall is only 3. If rainfall is only 3, all the water will go into the ground. See, this value is more, let us say it is 5. Just assume it is 5. Ground can absorb 5, but rainfall is only 3. Ground can absorb 5, but rainfall is only 3, which means only 3 will go into the ground. Yes or no? Only 3 will go into the ground. Yes, sir, understood clearly. So whenever intensity of rainfall is less, than f, then in that case, if I want to find infiltration, will be simply I into t. 3 into 1, I into t, this area. Yes or no? Here also you have to multiply it by 2 into t. Understood? Now tell me, Sushil, is this thing clear? So whenever you have less intensity of rainfall, whenever rainfall is less, that entire rainfall will go into the ground. So you have to find the area of rainfall. You have to find the area of this rectangle here. Okay, so whenever rainfall intensity is less, you find the area of rectangle, and whenever intensity of rainfall is more, you will integrate to find the infiltration area, and the remaining area will give you runoff. This is runoff. Okay, is this thing clear? Okay, Sushil. Understood? So this is the ultimate concept here. This is the ultimate concept. This you have to remember. If we are simply integrating, from 0 to t, listen Sushil very carefully. If we are simply integrating from 0 to t, we are assuming, see, we have solved some questions yesterday. Let me show you some questions. See, we have solved some questions here. See, we have simply integrated from 0 to 3 by 4. We are assuming one thing here, that intensity of rainfall is more. We are assuming here the intensity of rainfall will be more. Okay. We are simply assuming. If intensity of rainfall is not more, then how come this amount of water will go into the ground? If intensity of rainfall is less, then obviously this much amount of water cannot go into the, because rain is not there. Okay. So when we integrate directly, it means intensity is less. We have made an assumption that intensity of rainfall is more. We have more rainfall, so that ground is getting sufficient moisture. Okay, so I hope this thing is clear. So this is the beautiful example with the help of which I hope you are able to understand when you have to take rectangular part and when you have to take integration part. Rectangular area you have to take when intensity of rainfall is less, and integration part you have to take when intensity of rainfall is more. Okay. Okay, it's perfectly clear. Now we'll move ahead with phi index. Now we'll discuss what phi index is. Okay, now we'll discuss what phi index is. So see, we have just now understood infiltration curve. Okay, just now we have understood what infiltration curve is. So let me expand this. Wait a second. So now if you want to understand phi index, see, whenever in questions they will ask you to compute phi index, what you have to do first? Firstly, you have to do hydrograph every time. Listen very carefully. This is very, very important topic. Okay, many a times this has also been asked in examinations. Okay, so listen very carefully here. Listen very carefully. So let us say we have to find phi index. Sir, first first tell me, sir, what is phi index? Sir, first tell me what is the meaning of phi index. So the meaning of phi index you will understand only by drawing hydrograph. Only the very first thing which you have to do every time whenever it comes to phi index, draw hydrograph first. Okay, so let us assume we have this certain kind of hydrograph here. Okay, let us assume here, let me draw it by hand itself. So let us say this is your intensity time graph. Okay. Let us assume this is your intensity time, this is your intensity versus time graph. Okay, now sir, what is the meaning of phi index? Phi index is simply the value of average rainfall. Listen very carefully. Let me draw a line here. Let me draw a random line here. Okay, let me draw a random line here. Let us say this line. Let us say we have drawn this line. Okay, and let us say if this line is representing if this line is representing phi index, then what is the meaning of this phi index? See, this phi index is a kind of average rainfall. Listen very carefully. Okay, be very attentive. Listen very carefully. Sir, this phi index is giving you a kind of average rainfall, below which all the volume of rainfall is equal to infiltration, and above which all the volume of rainfall is equal to runoff. Sir, explain it again. See, the area above this line, if you want to find the area of rainfall, above this phi index, this will give you runoff volume. Yes or no? See, let me explain it with the help of an example so that it is very, very clear to you. Okay, let me take an example here. With the help of which you are able to understand beautifully what phi index exactly is. Okay, so let us take an example. Okay, in this question, see, this question has been asked in examination. This kind of question has been asked in real examination. So let me take one beautiful concept here. Okay, so they are saying rainfall is happening for 4 hours. Intensity of which in the first hour, second hour, third hour, and fourth hour. First hour, second hour, third hour, fourth hour. This is your intensity part, centimeter per hour. Okay. Intensity in the first hour is 3. In this 5. This is 2. This is 4 centimeter per hour. Okay. Intensities are given to you perfectly here. Okay. So they are saying here, find. They are simply saying find the total runoff. Find the total runoff volume. Find the total runoff. Find the total runoff volume if phi index. If phi index is 3. Let us take it as 3.5. If phi index is 3.5 centimeter per hour on an area of let us say 100 hectares. Okay, so this is the question. With the help of this question, you will be easily able to understand what phi index exactly is. Okay, so sir, you are giving me intensity versus time graph. You are giving me intensity versus time graph. Like, see, this is obviously showing you the rainfall pattern. Rainfall intensity versus time graph is showing you rainfall pattern. Okay. See, when this playlist will be complete, SK, you will become champion in hydrology. Not even a single question will be wrong. Okay, I am challenging you. So just stay patient. See, the end date of this will be not more than the end of this March. Okay, so by the end of this March, definitely we'll finish it. Okay, so what I'm saying here, find the total runoff volume if this is there. Okay, so 5 is equal to 3.5 means, see, 3.5 is above 3.3 only, so I will draw a line here. Okay, this is your phi index. This is your phi index, which is, I've drawn a line here, which is phi. See, phi index is a kind of average value, so it will be drawn straight. I already told you in the last class that average value is denoted by average value. Yes, average value is denoted by a straight line. Okay, so it's a kind of average rainfall. Okay, so what we have to do, we have to find runoff. So tell me, I am now going to ask you some questions. Tell me in the first hour. Okay, so we have 4 hour, 1, 2, 3, 4. Tell me for first hour, what will be the runoff? Can you tell me for the first hour, what will be the runoff? Can you tell me? Sir, in the first hour, phi index means infiltration. Phi index means kind of infiltration. Sir, infiltration is 3.5, but rainfall is 3. Rainfall is 3, infiltration is 3.5. Sir, in the first hour, I can see that intensity of rainfall is less than 5. Intensity of rainfall is less than 5. So I will say no runoff. Zero runoff will take place. Why? Because infiltration line is more and intensity of rainfall is less. Rainfall is less. Great. Yashu, you are from CSE. Great. Perfect. 0. Yes. In the first hour, runoff is 0. Now tell me for second hour. Tell me for second hour, what will be the runoff? For second hour, sir, runoff will be rainfall intensity minus phi into T. Okay. So, sir, rainfall intensity for the second hour is 5. This is 3.5. 5 minus 3.5 is, sir, this is 5 centimeter per hour. This is 3.5 centimeter per hour. Okay, out of 5 centimeter per hour, 3.5 is going into the ground. So how much is remaining? Multiply by 1 hour. How much is remaining? 1.5 centimeter per hour is your runoff intensity. Multiply by 1 hour, because this is 1 hour only, so we will get 1.5 centimeter. Yes or no? You will get it as 1.5 centimeter. Perfect. For third hour, tell me for third hour, how much is your runoff? Sir, obviously for third hour, runoff will be, for third hour, sir, again, I can see that intensity of rainfall is less than 5. Intensity is 2. Infiltration is 3.5. So obviously no runoff. All the water will go into the ground. Obviously in this case also no runoff. This case also will give you no runoff. And similarly for the fourth hour, for last hour, for fourth hour, sir, for fourth hour we have to understand 4 minus 3.5, 4 minus 3.5 into 1. Okay, so this will be 0.5 centimeter. So if I want to evaluate the total runoff, if I want to write down the total runoff will be equal to, and this total runoff will be basically in second and fourth hour. Okay, will be equal to 1.5 plus 0.5, which is 2 centimeters. Okay, this will be denoted, listen very carefully, this will be denoted with this area 1.5 and 0.5. This is 1.5, this is 0.5. Is this thing clear? This is runoff. So listen very carefully now. The value above phi index, the value of the volume of rainfall, basically the value of rainfall above phi index, the value of rainfall above phi index gives you runoff. Is this thing clear? Yes. So this is the main definition. And the value of rainfall which is below phi index, see, let me color it with blue. Tell me the value of rainfall. Let us find the value of rainfall below phi index. Okay, let us find it. Listen very carefully. So this is the value of rainfall below phi index for the first hour. This is the value of rainfall below phi index for second hour. This is the value of rainfall below phi index for the third hour. This is the value of rainfall. This is the value of rainfall for the fourth hour below phi index. Okay, so this is what, this is infiltration. Sir, simply you can say below this phi thing, below this phi, the whatever volume we have, whatever rainfall volume we have will be equal to infiltration volume. And above this phi thing, whatever volume of rainfall is there, that is your runoff. That will indicate a runoff. Now is this thing clear? So what is phi? Sir, phi is segregating runoff and infiltration. If you have a hydrograph, hydrograph means rainfall intensity versus time, then this phi index will segregate. Above part will give you runoff volume, below part will give you infiltration volume. Is this thing clear? Tell me. So if I want to find total infiltration here, I can simply find it by total infiltration by finding this area, or simply what you can do, you can find you can also do P minus R. You can do P minus R, or you can do this 3 plus 3.5, 2 plus 3.5. This is 3. This is 3.5. Okay. This is 5, na? This is 5. 5 is 3.5. 2 plus 3.5. Plus 2 plus 3.5. So 7 plus 5 is 12 centimeter. You are absolutely correct. And the total rainfall will be 14. Out of total 14 centimeter, 12 is going inside the ground. And 2 is taking part in the form of runoff. See, this phi index is a theoretical concept. In actual practice, I told you, infiltration is taking place like this. If you will find infiltration using this, then you have to find this area. You have to find this area under this graph. When you will find the area under infiltration curve, as we have already solved earlier, okay, then you will get the same infiltration value. But if you want to solve this from a kind of average infiltration value, this is a kind of average infiltration index, phi index. It gives you average infiltration value. Okay, then also the value of runoff or infiltration which you are getting will also be the same. Okay, it is just a concept of average. So I hope with the help of this example, what phi index is exactly clear to you. So basically, sir, you are saying that phi index is representing average. It is a kind of average infiltration index which denotes segregation between runoff volume and infiltration volume. Okay, so let me write down the basic definition. What is phi index? If someone asks me like what is phi index, I will tell it is the average rainfall. Above which above which rainfall volume is equal to, can you tell me, can you fill in this blank? Above which rainfall volume is equal to, can you tell this thing? Can you tell this thing? Above which rainfall volume is equal to, can you tell the answer? Can you tell the answer to this one? Yes, rainfall runoff volume. Perfect, Sushil. Above which rainfall volume is equal to runoff volume. Above which rainfall volume is equal to runoff volume. Perfect. And below which rainfall volume is equal to infiltration. But we have to understand. See, the white area which we are showing here is runoff. The white area which we are showing here is runoff simply. Okay. And the shaded portion, let us draw with this. This area is being represented by, this area is being represented as infiltration. Now one thing, now most importantly, the formula for phi. Okay, what is the formula for phi indexer? The formula for, see, you all know that total precipitation has two components. One is infiltration, next is runoff. Okay, some part will go into runoff and some will go into the ground. So this infiltration part is phi into T, infiltration index multiplied by time. So from here, the value of phi which you will get is P minus R upon T. Okay, P minus R upon T. So I will write the direct formula here. Phi index is equal to P minus R upon TE, excess time. Remember this formula, very important. This is phi index. Now, it is a kind of infiltration value. It is a kind of average infiltration value. Now, what is P? P is total total rainfall. R is total runoff, and this T is excess time. Now, what is the meaning of excess time? See, this T means, listen very carefully. This T means excess time. So we have to understand on concept here. What is the meaning of excess time? Excess time is that time in which excess rainfall occurs. Excess time is that time, or time excess is that time, sir, it is that time in which rainfall excess occurs, in which excess rainfall takes place, in which excess rainfall occurs. Okay, what is the meaning of excess rainfall? See, you have 5 hours here. Okay, 0, 1, 2, 3, 4, 5. Can you tell me in how many hours here, we have excess rainfall? See, excess rainfall means the value of intensity of rainfall is more than 5. If value of intensity of rainfall is more than 5, then I will say that in that case excess rainfall is there, extra rainfall is there, which will be able to run off. Yes or no? Tell me in this example, what is the value of excess time? So, sir, in this hour intensity is more, in this hour also intensity is more, in the third hour also intensity is more, in fourth hour intensity is less. Sir, in fourth hour, since intensity is less, no runoff, because we have no excess rainfall. Okay, sir, here I can see extra rainfall is there, here also extra rainfall, here also excess rainfall, and in the last hour also we have excess rainfall. So total we have 4 hours. In which you have here, total we have 4 hours in which excess rainfall is there. Okay, so excess rainfall means runoff. Excess rainfall indicates runoff. Yes or no? Excess rainfall indicates runoff. Yes or no? Indicates runoff volume. Okay, indicates runoff volume. So whatever this white portion, this is your excess rainfall, excess will give you runoff volume. Simple. So yes, so total duration See, if we want to find phi, obviously this excess time will be 4 hours. Okay, we are only interested in this. Okay, we are not interested in the fourth hour. We will only find phi with the help of these 4 hours only. We will write p, we will subtract runoff. Okay, let us take an example with the help of which we will find phi index. So what are the method to find, what is the methodology if in question hydrograph is given to you and runoff is given to you? How you will find, if precipitation chart is given to you and runoff thing is given to you, how you will find phi index? For that we have a methodology. Okay, so let us try to understand that. So how to find phi index? What you have to do, listen very carefully, this is important. Okay, this is very important because generally people get confused with this, so please pay attention here. Yes, how to find phi index. Yes, how to find phi index. So very first step is, the very first step is, whatever question you have, whatever question, okay, no matter whatever kind of question you get, firstly you have to draw the hydrograph. Okay, the very first step is, draw hydrograph. Okay, the very first step is draw hydrograph. Clear, sir? I will draw I versus time graph. Okay, no problem, sir, very simple. Second, okay, second, you have to take trials. Okay, assume 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 all intensities of rainfall are greater than phi. I will assume that all the intensities of rainfall are greater than phi. Assuming all intensity of rainfall is greater than phi, find phi value, find phi index in first trial. Okay, we have to take many trials. Okay, we have to take many trials. Okay, find phi index in first trial. If now you have assumed that all the I are greater than 5. You have assumed that all the I are greater than 5. If all the I are greater than 5 for actual, then we'll stop. No problem. No problem. We have two methods. Okay. If all I as assumed are greater than 5, then stop trial. Then stop the trial. Then stop the trial. There is no need to repeat the process again and again. Then stop the trial. But let us say for even a single value, let us say if all I are greater than 5, no problem, that we have already assumed. I will get the phi value directly. But if even if single I value, even if one intensity is less than 5, then take another trial after removing this precipitation value. After removing this precipitation value, after this removing this I into T part. Okay, because in this we don't have excess rainfall, and we have to repeat this process again and again. Repeat step 2, 3 and 4. Repeat step 2, 3 and 4 until we get I greater than 5 for all the remaining values. Okay, so what is the meaning of this? This we will understand with the help of a beautiful example. Then all the things will be clear to you. Okay, so we will solve one question with the help of which you will be able to find the phi index. Okay, now, so let us solve one question. With the help of that we will easily able to understand the concept of phi index. Okay, so wait a second. Okay, so this is the question. In this question we will apply those steps and we'll find phi index every time. We'll use this method only. Okay, network issue is there, no problem. You can join later or watch the recorded videos, no problem. Okay, so sir, you are saying we have to find phi index here. Okay, in this question it is saying we have to find phi index. How? So sir, you have told me the very first step is draw hydrograph. Sir, you have told me. Okay, I will not do anything. I will, in the very first step, I will draw hydrograph. Okay, so they are saying how I will find phi index. Be very attentive here. Listen very carefully. Please be focused. So they are saying 6 hour rainfall produced intensities of 7, 18, 25, 12, 10, 3 centimeter per hour. Okay. For 6 hour rainfall is there for 6 hours. In the very first hour we have 17, then second hour 18, like this. So on and so forth. We have 6 rainfall intensities in 6 hours. The runoff produced is 36 centimeter. Find the value of phi index. Okay, sir. Okay. So, sir, you have told me, as you have told me, sir, I have to draw I versus T graph first. So I will draw it here. Okay, I will draw it here. Yes. So this is my y-axis, which will give me intensity of rainfall, and on the x-axis we will have on the x-axis we have, sir. So let me draw the graph here. So this is 7. Let us say this is 7. This is 7. Let us say this is 18. Then we have 25, which is even greater. Okay, let us say this is 25 centimeter per hour. Okay, sir. Then we have 12. 7, 18. Let me write here 7, 18, 25. 12 will be somewhere here, obviously. 12, 12, 10, and 3 at last. And 3 at last. This is 12, this is 10, this is 3. Okay. Perfect, sir. Perfect. So this is my intensity versus time graph. This should be more straight. That's why I have drawn it again. So, okay. So this is my intensity, which will be in centimeter per hour. And here we have time. Here we have time, which is in hour. Now, first step is done. Sir, clear. This is for first hour, second hour, third hour, fourth hour, fifth hour, and sixth hour. Drawn, sir. Now the second step is what you are saying in the second step. Sir, in the second step you are saying, where is the steps? Yes. First step is done. Now assume all I are greater than phi. I will assume that whatever phi value we are going to obtain in the first trial is less than all the I values. Okay, I am going to assume this. I am going, see, remember this formula, we'll use this formula. Okay, sir, no problem. Listen very carefully, otherwise you will get confused. I'm 100% sure. See, we will take trial 1. First, what I will assume, sir, you are saying, sir, assuming all the I values are greater than phi. What does it mean? Sir, whatever phi index I will get, that phi index will be even less than 3, because sir, I am assuming in this case that phi value will be less than this value 7, 18, 25, 12, 10, 3. It will be less than all the I values. Okay, I am assuming that phi value will be less than all the I values. Is this thing clear? Okay. Okay, I am assuming here that all the I values are more and phi is less. So that why we are assuming this? Because we have to make sure that we have rainfall excess here also, we have rainfall excess here, we have rainfall excess here also, rainfall excess here also, rainfall excess here also, rainfall excess here also. So sir, we have taken phi value even less than all I. Why? Because excess time will be 6. See, if I am assuming all I are greater than phi, which this means that in all the duration, in all the time period, we have excess rainfall, extra rainfall, where runoff is taking place. Okay. So I am assuming phi value is less than all the phi, so that excess rainfall occurs, during entire duration. Yes or no? That's why I've assumed this. Okay, that's why I'm assuming it, which means that excess time is equal to 6 hour. Okay, so according to my assumption, let us see if we are correct or not. Let us solve the value of phi and let us wish if it is less than 3 hours, then it is correct. Oh, sorry, 3 centimeter per hour. If it is less than 3 centimeter per hour, then it is okay. Okay, sir. So we'll take trial number 1. We will take trial number 1. No issues, sir. We will take it. Find the value of phi. Formula for phi is P minus R upon excess time. First, let us find the total value of P. Okay, the total value of P will be, tell me how much. See, 7 centimeter per hour multiplied by 1 will be 7. See, this area is 7, this is 18. Simply sum up, find the area of all these bars, rectangles, and sum it up. That will give you the total precipitation. So total precipitation will be 7 plus 18 is 25, 25 plus 25 is 50, 50 plus 12 is 62, 62 plus 10 is 72, 72 plus 3 is 75. So total precipitation will be 7 plus 18 plus 25 plus 12, 10 and 3, which will be equal to 75 centimeter. Understood, sir? Understood. And runoff which they are giving in question is 33 centimeter. Runoff is 33. So the value of phi is P minus R upon excess time. The value of phi is P minus R upon excess time. So P means 75 centimeter. P means 75 centimeter, and R means runoff, which is 33 centimeter. Understood, sir? What is the value of excess time? What is the value of excess time here? The value of excess time is 6 hours. Okay, the value of excess time is 6 hours. That is also clear. Now divide them. Tell me how much you are getting here. So this is when you will subtract it, you will get it as 42. 42 upon 6 is 7 centimeter per hour. 7 centimeter. Okay, perfect. Now the thing is we are in trouble. Why? Because we have assumed that all the I values are greater. But sir, if I will draw this 7 centimeter per hour thing, okay, see, 7 centimeter per hour will pass from here, from 7 only. Okay, this is our first value of phi which we are getting here, 7 centimeter per hour. Sir, we have assumed that phi value was even less than 3. We have assumed that phi value was less than all the intensities of rainfall. Yes or no? But unfortunately we are not getting it. If we would have got value of phi less than 3, then the trial would have ended here only and the answer would have been 7 centimeter per hour only. Okay, but since we are getting it more, you can see here that phi value is coming more than 3 and this 7. Okay, now what I will do, sir, our assumption is gone. Now our assumption is wrong. Okay, can you see that assumption is wrong here? Can you understand our assumption, the very first step is wrong? Now what I will do, now I have to remove, see, all those intensities of rainfall which are equal to phi and which are less than phi. Which are equal to phi, see, sir, this intensity of rainfall is equal to phi and this is less than phi. So I will remove these values. I have to remove them now. Okay, these two have done blunder, because of which, sir, my phi value, we have to take trial again. Okay, so I will do trial again. With the remaining values. I will do trial again. This will be my trial number 2. And in this trial number 2, what I have to do? I have to remove all those values. Okay, now I will write here, remove all I which are less than and equal to phi. Remove all I which are less than equal to phi and find phi for the remaining excess time. And find phi for remaining excess time. Now can you tell me what is the remaining excess time? For remaining excess time, can you tell me what is the excess time here? Now after finding the phi value for the first time, we can for sure say that excess time is 4 hour only. Sir, I can see excess rainfall. In this second hour, in this third hour, in this fourth hour, and in this fifth hour. Second, third, fourth, fifth, in this 4 hours only, I can see excess rainfall, extra rainfall. The value of rainfall is above 5. Is this thing clear? Why I am removing 7 and 3? Why I have to remove them? Because they are showing no excess. Okay, all those intensities which are not showing excess after the first trial, all those intensities which are not showing excess, I have to remove them. Is this thing clear? I have to remove them. I have to remove them, sir. Understood. Okay, I have to remove them. This is the third step. I have told you. I have told you this is the third step. Okay. If all I are greater than 5, then no problem. Trial would stop. But this has not happened. Even if single I is less than and equal, sorry. Even if a single I is less than equal to 5, then take another trial after removing this. After removing this I, this is not it. This is I into T. Okay, this is not it. This is I into T. So let us solve here. Okay, now sir, what I will do? So I have to remove them. So I will find another phi. I will find another phi P minus R upon excess time. Okay, so P is 75. So out of this 75, sir, we have to remove this 7 thing. We have to remove this 3 thing. Why? Because they are not in excess now. Because they are not in excess now. See, phi value will only be calculated when you have excess rainfall. Sir, the concept is phi value will only be calculated when you have excess rainfall. Okay, so I have to remove this 7 and I have to remove this 3. Subtract it, sir. Remove it. Wherever you don't have excess, wherever you don't have excess rainfall, remove it for sure. Okay, sir. So from total precipitation, I have removed this first hour rainfall and the last hour rainfall, 7 and 3. Runoff will be same. Runoff will be same. Now, can you tell me what will the excess time? Now, can you tell me what will the excess time? I will now calculate phi value for the next time only for these 4. Now I will find phi value only for these 4. Now I am not touching the first hour and the 6th hour. I have removed it. Now I will find phi value considering only this data, not these. Okay. So the excess time will be 6 minus 2. We will remove this and this. Perfect. We will remove this and this. We are only calculating phi index for these 4 hours. We are not interested in last part and first part. Okay. So what you will get here? What you will get here? Sir, when I will solve this, I will get it as, tell me how much we are getting here. This is 32. This is 32 upon 4. 32 upon 4 will be 8. Let me check again. Yes, 65 minus 33. Yes, perfect. 32 upon 4 is 8 centimeter per hour. Okay, I hope you are also getting 8 centimeter per hour. Now, this is the second trial. So I will draw it again. Okay, now I will draw it again. Okay, sir. I have to draw it again. So this is above 7, you have 8. So this is 8 centimeter per hour. This is 8 centimeter per hour. This is our second trial. Now again we have to check. But now you will check only for these remaining 4. Now whatever check you have to apply, you will check for only these 4. Now check. Tell me if in these remaining 4 hours excess rainfall is there or not. Sir, in this first hour 18 is more than 8. Okay. 25 is more than 8. That is also okay. 12 is more than 8. 10 is more than 8. So no problem, sir. Now all the I values, intensity of rainfall are more than 5. Now all the remaining I greater than 5. So I will stop here. Okay. Now I is more than 5 for all the remaining values. Okay. After repeating, I will stop here. Repeat step 2 and 3 until we get I is greater than 5. So now all the I's are greater than 5 for the remaining values. So stop the trial. I hope this thing is clear. Okay, so stop the trial. So the final value of phi will be, will be 8 centimeter per hour. Okay, I will write here that for remaining phi, remaining I values for 4 hours, are greater than phi, that is excess rainfall is there, rainfall excess is there, we will stop the trial. So final value of phi is 8 centimeter per hour. This is how you will solve the value of phi. Okay, sir. Now tell me now the question arises, why you are taking so many trials, okay, to finalize the value? This is the ultimate part. See, we are taking so many trials to finalize our phi value so that runoff becomes equal to 33. See, in this question they are saying runoff is 33 centimeter. You are adjusting this phi value. Firstly, this value is coming as 7, then it is coming as 8. Why we are changing it again and again? We are changing it so that the area above this phi, listen very carefully, okay, we are changing this phi value again and again, so that the area above phi so that the area above phi so that the area above phi is equal to runoff volume. Okay, we adjust the phi value until the area above phi index is equal to 33 centimeter, is equal to runoff volume. Yes or no? Tell me this thing. We adjust it till we get the excess rainfall equal to runoff volume. Okay, we will check it here. We will also check. No need to worry. We will also check here. We will check here that if this excess rainfall, the value of rainfall volume above phi index, is it equal to runoff volume or not? Okay, so we'll check. So tell me, 18 minus 8, 25 minus 8, 12 minus 8, 10 minus 8. How much this will be? If I want to evaluate runoff, okay, we can check it also. We can cross check also if I have solved the value of phi correctly. If you want to check it, find the total runoff. Okay, so total runoff will be equal to, sir, it will be 18 minus, see this is 8, 18 minus 8, 25 minus 8, let me write here, 18 minus 8, then 25 minus 8, then 12 minus 8, and then 10 minus 8. Tell me if this is coming out to be 33 or not. Tell me. So sir, this is 10, 25 minus 8 is 17, 12 minus 8 is 4, this is 2, so 27 plus 4, 31, 32, yes, plus 2, 33 centimeter. So this means your phi index is absolutely correct. Okay. You are unable to sleep. Okay, if you are unable to sleep, I have one very great remedy for that. See, sometimes I am also unable to sleep because sometimes we don't get too much tired. Okay, basically two things you can do. Do some physical activity. Secondly, the best remedy which I do, okay, see some NPTEL lecture. Okay, see some boring kind of lecture, simply see it. After seeing it for 15 hours, 15 minutes, okay, not 15 hours, after seeing it for 15 minutes, you will automatically be sleepy. Okay, so this is the best remedy which I practice when I want to sleep. Okay, so you can perform this. This is the best remedy. Okay, or simply go to study. See, this I have performed yesterday only. Okay, yesterday till 2 p.m. Actually, after this class, I'm very much energetic. Okay, when I go to bed, I'm unable to sleep quickly. So what I do this thing only. I play some boring lecture and try to focus on it. Whenever, as soon as I start focusing on it, immediately I feel sleepy. Okay, no issues. So you can do this thing. So what I was telling here is that phi value is 8 centimeter, runoff is this. Okay, now infiltration part. Can you get the infiltration value? See, infiltration, if I want to draw in this diagram, infiltration will be denoted by this. Okay, this is infiltration. See, the area below phi, you have to find. Okay, the area below phi. This is infiltration, this is infiltration, this is infiltration. Now forget about 7. Now forget 7. 7 is not important, only 8 is important. Okay, the value which you are getting as final value, that will be important. 7 was the first trial, so we are not interested in that part. Okay, so infiltration is 7 plus 8 plus 8 plus 8 plus 8 plus 3. So 8 for the 32, 32 plus 10 is 42. Infiltration is 42. Okay, and if you want to find infiltration here, what you can do from total precipitation, you can subtract runoff. Total precipitation is 75 centimeter. Runoff is 33 centimeter. That is already given to you. When you subtract it, you will get it as 42. And from the graph itself, and from the graph also, you will be able to solve. And from the graph itself, you will be able to solve 42. Okay, 7, 8, 8. Let me write here also. Let me write it here also. This is 7. This is 8. This is 8. This is 8. This is 8. This is 3. So the volume which is below 5, the volume which is below 5 represents infiltration, and the volume which is above 5 gives you runoff. I hope now phi index is very, very clear to you. Okay, now we have one more index which is known as W index, that we also have to find. So now you are comfortable in finding phi index. Tell me. Everyone kindly comment now if you are able to find phi index comfortably. Then type yes in the comment box. Type yes in the comment box. I hope all the concepts are clear to you. So basically, the most important thing which you have to remember is the most important thing which you have to remember is that phi index is evaluated only for excess time, excess rainfall, when excess rainfall is there. So repeat again. Phi index is only evaluated for that time. Phi index is only evaluated for that time when we have excess rainfall, when we have extra rainfall, excess rainfall, when we have runoff. In that time duration only, in that excess time only, we will calculate phi index. Okay, we are not interested in the intensity of, we are not interested in that rainfall which is less than 5. We will remove it. We will only solve phi index. We will only solve phi index from those values which will give you excess rainfall. This is the ultimate concept. Okay, I hope this is very, very clear to you. Remember it. You can write it somewhere. Okay, phi index is only representing, or you can say is only calculated when you have excess rainfall. Okay, when you have excess time, excess rainfall, that's why you are only dividing it by 4. Okay, the final phi value which you are getting here is, you are getting for only 4 hours, not for 6 hours. Okay, understood, sir. Now tell me what is W index. Okay, sir, now tell me what is W index. See, W index is even better than phi index. Okay, W index is even better than phi index. Why, sir? It is a refined version of phi index. It is better than, it is a kind of modification in phi index. Okay, phi index, see, one drawback is there in phi index which is removed in W index. It is a refined version. It is a defined version of phi index because it considers initial losses. It considers initial losses such as interception, depression storage, etc. Okay, depression storage, etc. Which means, listen very carefully. See, you all know that if you want to find infiltration for actual, then out of total precipitation, you have to subtract runoff, but you also have to subtract some initial losses, because out of total precipitation, some part will obviously go into runoff, that is for sure. But some part is also going into infiltration, interception also. Some part is going in depression storage. Some part is going in evapotranspiration, like this. Okay, so out of total rainfall, we have to subtract runoff, that is for sure. But some initial losses are also there. Okay, whatever water will remain, that will go into the ground. So, sir, for phi index, basically what we do P minus R. Sir, we don't subtract depression storage, we don't subtract interception. That's why it is not perfect. Sir, we basically neglect all the minor losses. Therefore, if you want to find W index, W index is denoted by W, obviously. Okay, let me write W index. So W index is evaluated P minus R. Okay, P minus R minus your initial losses. This IA is initial losses divided by time. So can you tell me, see, this is phi thing. If you will subtract something from phi, obviously W index will be less than phi or not. Tell me. The value of phi index is more and W index is less. Let me not write it here. let me write W index here. W index is less than phi index. Why? Sir, because we have subtracted initial losses also. Initial losses such as interception, depression, storage, evapotranspiration, like that. Yes or no? What is the use of phi index? Very good. The use of phi index is to calculate runoff volume. Okay. The use of phi index I have explained to you in this example. What? Yes, this one. Okay. This example is purely showing you the use of what? Phi index. If you have phi index, see, I told you we have this much of runoff. Now runoff is 2 centimeter and they are saying find the runoff volume. So how you will find runoff volume here? Tell me, Sushil. How you will find runoff volume? Sir, firstly, I will find the runoff depth in all the R's. Okay, for the first R, second R, like this with the help of phi index. Then I will multiply this runoff depth by the area. Okay, I will multiply this runoff depth by the area to get the volume. So this 2 centimeter is 2 by 100 meter, and 100 hectare, you all know 1 hectare is 10 power 4 meter square. So the total value of runoff volume will be 2 into 10 power 4. That means 20,000 meter cube runoff will take place. 20,000 meter cube runoff will take place from this field. How come you have calculated this? With the help of phi index. Okay, you have calculated, Sushil, with the help of phi index. So I hope the application of phi index is clear to you. The application of phi index is to evaluate runoff. To evaluate runoff. Yes or no? Tell me. Once you get runoff depth, you will multiply that by the area. You will get runoff volume. Is this thing clear? Okay. Perfect. I hope the entire concept of phi index, W index, all these things are clear to you. Okay. Now we'll solve one question. With that, we'll end. Okay. This is our last question. We'll solve this question. After this, we'll end, and tomorrow we'll start runoff. Okay. So abstraction from precipitation, one of the most important topics of hydrology, that has also been completed. Okay. So we'll solve this question. After this, tomorrow we'll start with runoff chapter. Okay. So let us take this question. A 4-hour storm had 4 centimeter of rainfall. Okay. And the resulting direct runoff was 2. If the phi index remains same, the runoff due to 10 centimeter rainfall in 8 hours in the catchment is. See, from the first data, you have to find phi index. From the first data, 4 4 centimeter, 2 runoff, you have to find phi index, and that phi index you have to use again. So can you do it? Yes or no? This is a kind of question which has been asked in GATE examination. So if you want to solve it, how I will solve it? See, from the first storm where rainfall is 4 centimeter, duration is 4 hour, and runoff is 2 centimeter. This is the first line of your question. So if you want to evaluate phi index from here, the value of phi index will be total precipitation minus runoff divided by excess time. Okay. So this is 4 minus 2 divided by 4 hours. So the average infiltration value is 0.5 centimeter per hour. Is this thing clear? Now they are saying phi index remains same. Now they are saying for case 2, phi index remains same. So phi value will be same. Yes or no? Phi is 0.5 centimeter per hour for the second case. Total runoff due to 10 centimeter rainfall, that means precipitation is 10 centimeter. Duration is 8 hours. We have to find runoff. Okay, we have to find runoff. So how I will find runoff? Tell me. Tell me how I will find runoff. Can you find runoff? Yes, sir. Obviously. See, runoff from here is phi into T. Bring runoff here, bring phi into T here. So runoff is P minus phi T. Runoff is P minus phi T. Yes or no? Runoff will be total precipitation minus infiltration. Infiltration is phi into T. This is infiltration. This is infiltration. Okay. So total precipitation is 10 centimeter. Loss is 0.5 centimeter per hour. That means in every hour, 0.5 centimeter water is going into the ground. Phi indicates average infiltration. 0.5 centimeter water is going into the ground every hour. So in 8 hours, how much water will go? So in 8 hours, how much water will go into the ground? 4. Okay. In 8 hours, how much water will go into the ground? It will be 4 centimeter. So this is 6 centimeter. So final answer will be 6 centimeter. Okay. So I hope this numerical is clear to you. Perfect. Great. So I hope such kind of numericals you can easily solve. So this is the one numerical which has been asked in engineering services prelims. So I hope this is also very clear to you. Okay. So with the help of this example, we will end today. I hope W index is also clear to you, which is much better, or you can say refined version, in which we consider initial losses basically. If you will make these initial losses zero, then in that case phi index will be equal to W index, because this is phi only. This is phi. So you need to understand one thing. If initial losses are zero, then W and phi are same. But one thing is for sure, that W index is less than equal to phi index. If initial losses are zero, then it will be equal. This you need to remember. Okay. So I hope till here everything is clear to you. So great, we'll end the lecture today and we'll catch up tomorrow with runoff. So thank you everyone. Stay blessed. Good night. Take care. It's a request. Everyone, please revise and try to solve all the previous questions which has been asked in GATE and engineering services. With that, you will get confidence. Okay. So we'll catch up tomorrow with runoff. Good night, everyone.